This golden sand is the foundational element of every chapati recipe.
This separation is crucial to ensure only the pure kernel goes into the chapati flour. If the wheat is too wet, it will mold. If too dry, the atta flour will make brittle chapatis. This whole grain approach is why chapati flour is darker and healthier than white flour. A stream of cream-colored atta pours down a chute. It is not stark white, but a warm beige. Distance of it. The magnetic trap safety check. The stream of flour flows over strong rare earth magnets.
The color grading is slightly darker than the reference standard.
Yes, the spectrophotometer confirms the deviation.
A laser scans the pressed flour sample, checking for bran fleck density and overall whiteness.
A certain percentage of damage is required for water absorption, ensuring the chapati remains soft for days after baking.
This lipid layer will coat the flour particles, ensuring the finished chapati remains soft and pliable for days after baking.
The mixture is now a uniquely beige sour oil.
This is the moment where the chemistry of the chapati dough begins, initiating the bonding of gluten proteins.
The dough looks rough, torn, and lumpy. It is not yet a smooth mass.
The friction of the kneading generates heat. The dough glows orange against the cool blue metal.
The dough transitions from rough and matte to smooth and satiny. A slight sheen appears.
It stretches long and thin without snapping immediately. This elasticity is the guarantee that the chapati won't tear when pressed into a thin disc.
The dough falls gently into a large stainless steel funnel-shaped bin. This container is
An automated lid or plastic sheet descends over the hopper. This is crucial to prevent skinning or dry crust formation.
Natural enzymes like amylase break down starch into sugars. This biological process softens the dough and helps the chapati brown beautifully in the oven.
This first in, first out system ensures every batch of chapatis gets the exact same resting time.
The large spiral screw pushes the chapati dough forward toward the nozzle. It compresses the dough slightly. This strict weight control is the only way to guarantee every chapati bakes perfectly evenly. This tension is necessary so that when the ball is pressed, it snaps back slightly, creating the perfect chapati thickness.
The steam vent. As the plates compress the wet dough, a burst of white steam shoots out from the sides.
Macro time lapse of the opacity shift. Detail shot of the micro blistering. Tiny, pale bubbles, no larger than a pinhead, start to appear on the surface of the chapati.
We see the faint grid pattern of the steel conveyor belt toasted onto the dough. This texture is a hallmark of industrially baked chapatis.
As the chapati heats, water turns to steam. The new crust traps the moisture, causing pressure to build like a bomb.
Unlike raw dough which would fold, this semi-cooked disc lifts slightly but holds its flat shape. The chapati now has structural integrity.
If the chapati stays here too long, it becomes a hard cracker. Too short, and it will burst later. Precision is key.
This sealed epidermis is the critical engineering feature that differentiates a puffing chapati from a flat tortilla.
Here we see the gluten stretch in action. The network developed in stage 5 is holding the steam tight, keeping the chapati from bursting. The chapati glows bright white hot. The superheated steam inside cooks the dough from the inside out. Limit tension. A tiny jet of steam escapes, but the structure holds. This resilience is the mark of a high-quality chapati.
Action shot of the drape test. As the cool chapati travels over a roller to change direction, it bends completely over the curve without cracking.
Well, now that the chapati has deflated, the top skin is not smooth anymore. It has tiny, appetizing wrinkles where the fold.
The moisture equilibrium check. Sensors measure the relative humidity of the air around the cooling chapatis.
The finished bag of chapatis is slightly inflated, looking like a cushion. This gas buffer acts as an airbag.
This proves the seal is hermetic. If oxygen can't get in, the chapatis remain safe.
you
The chapatis inside bend easily without cracking. This tactile feedback confirms that the product is fresh and
Wheat flour, water, salt, oil.
That's fresh.
Into the trolley.
Here, try this one. It's fresh.
It smells wonderful. The hot pot really keeps them soft.
Can I have some curry, Mom?
This short texture confirms the quality of the gluten structure developed back in stage 5.